All right, check it out. Here we go. Another math-tastic video from Mr. D. All right, check it out. So we are doing tonight, we're working on graphing logarithmic functions. Okay, how do you graph those logarithmic functions? Well, it's really not too bad. All right, we can simply recall that log base b of x is equal to some y value. This is what the logarithmic equation says in logarithmic form. And then if we want to rewrite it in exponential form, which I think is actually easier to do when we are trying to graph, then we can write it as b to the y is equal to x. So exponential form when we're graphing. All right, so let's see. Let's consider some steps before we even start. 1, rewrite the equation in exponential form for the base. Okay, now we're going to shifting horizontally, shifting vertically, doing all these different shifts that we might encounter. And so we might have to write the logarithm in base form first. Now, we can build a base chart from an XY chart, and then what we can do is we can take that and then use it with the transformations that we see. We can build a transformation XY chart, and then we can graph the function. And one thing I think I want to cover as well, since we're here, is the fact that in some cases, well, not in some cases, we have a form of this, I'm bringing this over here, of y equals log of, and I'll put this in x minus h plus k. All right? So plus some k value. Now, let's talk for a quick second on what each of these are responsible for. If you recall, x minus h is responsible for the horizontal shift. Horizontal shift, right? And it does the opposite. So if h is positive, then it's going to go to the right. So if h is negative, then it's going to go, or if h is positive, it's going to, so it goes the opposite way. If I set x minus h equal to 0, I'll get x is equal to h. So remember, if it's a plus sign, you're actually going to shift left. If it's a negative sign in here, you're actually going to shift to the right. Okay, so it does the opposite of what you would think. K, on the other hand, this is our vertical shift. Vertical shift. Vertical shift. And it does whatever the sign says. If the sign is positive, then it's going to shift up. So if the sign is positive, it will shift up. And if the sign is negative, it will shift down. There is no trickiness with K. Okay? It doesn't try and fool you by, oh, wow, what do we have inside? So x minus h, however, do the opposite. If it's a plus sign, shift left. Negative sign inside, shift to the units of h to the way they want it there. All right. Let's continue on. So, turn my back to the camera, and let's look at an example. So we went through the steps, and now we want to figure out an example. I'm just going to slide this over here. All right. So let's take a look. Here we have log 3 of x plus 1. Right? They want us to graph that. And so again, this is the way I like to do it. You can do it however you want. But in my experience, the easiest way, the way that you arrive at an answer or a graph with less errors, in my opinion, is to do the base first. Okay? So we have an xy for the base, and the base in this case is just 3 to the y equals x. Now, I always like to use the same 3 values for y. Why? Why? Because it gives you a very consistent reaction to the x values. I use -1, 0, and 1. Now, why? Because 3 to the negative 1 power is always a fraction of with the representation of the base, so 1/3. If it were 2, it would be 1/2, 4, 1/4, etc. 0 always yields a 1, okay, because anything to the 0th power is 1. And 1 will always bring you the base back. So in that case, it's always a fraction of the base, representing the base, 1 and 3 for your x values. Now, we're going to look at this x plus 1 business here. And as we just discussed, since it's a plus sign, I should be moving everything to the left 1 unit. So I've got a transformation graph, and I build my xy chart. And above my x's, I'm going to make a little note to myself, hey, subtract 1. So what I do is I take 1/3 minus 1 is negative 2/3. 1 minus 1 is 0. 3 minus 1 is 2. So the transformations are complete for the x's. Now, did we do anything in the y category? No, we didn't. Reason why? No k value. Negative 1, 0. Those stay the same. I'm ready to graph. I go to negative 2/3 and negative 1, and I drop my dot. And then I go to 0, 0, put my point there, and finally at 2, 1, I put my other point, and I draw my curve. And we should see this thing hug relatively close to negative 1, because that is our transformation. We've moved the log function from 0, and we shifted it to the left at negative 1. So there you go. All right, now let's see one where we might have a vertical shift. All right, now, here we go. So we've got log 2 of x minus 2 plus 3. So again, I start off with the base, and it's 2 to the y equals x. So I build my base. Negative 1, 0, and 1 again. And what does it do? Oh, surprise, surprise. 1/2, right? 1 and 2. So that way we can always have the information for us there. Now, what I want to do is I want to build my transformation chart. And what did we do in here? It's a minus sign, so we end up adding 2. So I can make a little note to myself, hey, add 2. Plus 3 is a plus 3 in the y category. So these are my transformations. And all I do is I take the base and I add it to this, and so I make a new chart of my transformations. So once we do that, we get 1/2 plus 2 is 2.5. And you can write it as a fraction. It makes no difference. This is a mixed number, but that's okay. Negative 1 plus 3 is 2. 1 plus 2 is 3. And 0 is the x, plus 3 is 3. 2 plus 2 is 4, and 1 plus 3 is 4. So, and then I added an extra point of 6 and 5 because I wanted to see what would happen here. So, here's my point. 2.5 goes to 2. 3 goes to 3. 4 goes to 4. And I know it looks linear at this point. We're like, hey, that looks almost linear, but it's not. It curves. It does. Hence, we go to 6 and 5, and there's our last point there. All right, well, that is graphing logarithmic functions. Hope you had a great time. I know I did. And thanks again, Dykstra. Out. And don't forget, math that like button.